Quantum reality explained. Forget the chair you're sitting in. Forget the device in your hands, the floor beneath your feet, the very air you're breathing. For a moment, I want you to discard every single assumption you have about the world being solid, stable, and real. Because the bedrock of modern physics, the most successful scientific theory in human history, tells us that everything you see, everything you are, is a profound and beautiful illusion. The universe isn't built from tiny, solid marbles like some cosmic game of Legos. It's far stranger, more elegant, and infinitely more mysterious. The truth is, the universe is built from nothing more than invisible, intangible fields of potential. And you are not a collection of matter. You are a symphony of vibrations, a coherent pattern of energy, and echo reverberating through the fabric of reality. Let's start with something simple, your own hand. Hold it up. It looks solid, doesn't it? It feels solid. You can use it to knock on a wooden table, and the sharp, solid sound confirms your intuition. But let's zoom in. If we had a microscope powerful enough, we'd move past the skin, the cells, the molecules, and arrive at the atoms. And here, the illusion of solidity begins to completely disintegrate. An atom is famously, almost comically empty. If you were to scale up a hydrogen atom so that its nucleus, a single proton, was the size of a marble sitting in the center of a massive football stadium, the electron wouldn't even be a grain of sand. It would be a ghostly, probabilistic cloud, a smear of potential that fills the entire volume of that stadium. The actual stuff in the atom is infinitesimally small compared to the vast empty space it occupies. Your hand, the table, everything is composed of these atomic stadiums, making you 99.99999% empty space. But quantum physics pushes us to go even deeper, to a place where the words empty and space themselves lose their meaning. The old model of physics, the one we all learn in school, pictured electrons, protons, and neutrons as tiny, fundamental billiard balls. They were the smallest possible things, the ultimate building blocks. This picture is now completely obsolete. The revolution that shattered this idea is called quantum field theory, or QFT. And it doesn't just change the details, it rewrites the entire book on what it means to. QFT states that the most fundamental component of the universe isn't matter. It isn't even energy. The most fundamental thing is what is a field? You're already familiar with them. When you hold two magnets near each other, you can feel an invisible force pushing them apart or pulling them together. That's a magnetic field. The reason you're stuck to your chair and not floating off into space is because of Earth's gravitational field. These are invisible territories of influence that permeate space. Now imagine that has a field like this. QFT says that there is a field for every fundamental particle in the universe. There's an electron field, a quark field, a photon field, all layered on top of each other, all permeating every single nanometer of the cosmos, including the space you occupy right now. These fields are everywhere, like an invisible, multi-layered ocean. They are the true substance of reality. So if reality is just a bunch of invisible fields, where do the particles come from? Where is the electron, the photon, the stuff we can actually measure and interact with? This is the darkest, most beautiful secret of all. A particle isn't a particle is a vibration. It's an excitation. It's a ripple in the field. Imagine a perfectly still, calm pond. That pond is the quantum field in its lowest energy state, what we might call the vacuum or empty space. Now tap your finger on the surface. A ripple spreads out. That ripple, that localized little bundle of energy that travels across the pond, is the particle. An electron is nothing more than a ripple in the electron field. A photon of light is just a ripple in the electromagnetic field. Every particle in the universe is just a tiny localized vibration in its own specific universe-spanning field. This completely flips our understanding of existence on its head. Particles are not fundamental, fields are. Matter is not created from nothing, it is from the underlying potential of the fields. When we see particle-antiparticle pairs pop into existence in a vacuum, it's not magic. It's the field fluctuating, borrowing a bit of energy to create a momentary ripple which then subsides back into the calm. This also gives a profound new meaning to Einstein's famous equation, E equals mc squared. It's not just that energy and mass are equivalent, it's that mass is a form of concentrated vibrating energy. A particle's mass is a measure of how much energy it took to create that ripple in the field. So when you look at your hand again, you're not seeing a collection of tiny solid things. You are seeing a stupendously complex and stable pattern of trillions upon trillions of interacting ripples, a coherent dance of vibrations across a dozen different quantum fields. You are a song, a resonance, playing out across the silent orchestra of the cosmos. But if that's true, if you're just a ghost made of ripples in empty space, why can't you walk through a wall? Why does the world so undeniably solid?
The echo principle. The feeling of solidity, that hard, definitive sensation when you clap your hands or stub your toe, feels like the most real thing in the world. But as we've seen, it's a deception. If you are 99.999999% empty space, and the tiny bits of stuff you're made of are just vibrations in a field, then what exactly is happening when you touch something? The answer is as mind-bending as the problem itself. You have never, ever, in your entire life, actually touched anything. Not really. What you experience as touch is not contact. It is force. It is repulsion. It is the universe telling two things they cannot be in the same place at the same time. Let's go back to your hand and the table. Both are made of atoms. The outer layer of every atom is a cloud of electrons, those ghostly ripples in the electron field. As your hand approaches the table, the electron fields of your atoms get incredibly close to the electron fields of the table's atoms. All electrons carry a negative charge, and as you know from playing with magnets, like charges repel. The closer they get, the more powerfully their fields push against each other. The sensation you feel in your nerves, the feeling you call touch or solidity, is nothing more than the electromagnetic force screaming "no trespassing" on a microscopic scale. You are literally floating on an invisible cushion of force. You are not hitting a solid wall. You are being repelled by an energy field. But there's an even deeper, stranger rule at play here, a principle that gives structure to the entire universe. It's called the Pauli exclusion principle, and it's one of the cornerstones of quantum mechanics. In simple terms, it states that two identical particles of a certain class, called fermions, which include electrons, protons, and neutrons, the building blocks of all matter, cannot occupy the same quantum state simultaneously. This isn't a suggestion, it's a fundamental law of nature. It's less like a physical wall and more like a cosmic rule of information. Imagine trying to save two different computer files with the exact same name in the exact same folder. The system just won't allow it. The Pauli exclusion principle is the universe's version of that rule. It's what prevents electron clouds from simply passing through each other and collapsing into a singularity. It's the reason atoms have their structure, why chemistry works, why stars don't collapse, and why the floor holds you up. This is what we can call the echo principle. A particle isn't just the single point-like ripple in its field. It's the ripple, the rules it must obey, the forces it exerts, the information it carries. It comes with an echo of influence that extends around it. Your very existence is a collection of these echoes, these zones of influence, all interacting and repelling each other according to these fundamental quantum rules. When you push on a wall, the echoes of your particles are pushing against the echoes of the wall's particles. Solidity is the macroscopic experience of trillions of quantum echoes shouting their existence at one another. This is also where the bizarre nature of wave-particle duality comes into play. A particle isn't just a point, it's also a wave of probability. This wave describes where the particle be. When you bring two atoms together, their probability waves overlap, and the Pauli exclusion principle and electromagnetic forces dictate how those waves can interact, creating a stable, repulsive structure. The solid world is a grand illusion, built from the overlapping probabilities and repulsive forces of countless quantum waves. So, what are you? You are a complex, self-sustaining pattern of these echoes. You are a standing wave in the quantum ocean. Think of a chord played on a piano. The individual notes are just vibrations in the air. But when played together in a specific pattern, they create something more, a harmony, a piece of music. You are a harmony of quantum vibrations, a pattern of energy that has achieved a temporary, magnificent stability. Your consciousness, your thoughts, your feelings, they all arise from this impossibly intricate dance of energy fields governed by quantum laws. This redefines your connection to the cosmos. You are not a visitor here. You are not separate from the universe looking in. The fields that make up your body, the electron field, the quark fields, are not fields. They are the same fields that stretch to the farthest corners of the galaxy. You are a temporary, localized thought in the mind of the cosmos, a brief, beautiful echo in a quantum field.